Hello everyone. We are starting with this webinar. So let me introduce the hosts here. I'm Shikhar, Senior VP at GreyB, and I work with R&D teams, technology scouts, and open innovation managers for a variety of consulting projects. And with me, I have Arindam. Arindam, would you like to introduce yourself?
Hi, Shekhar. So I'm working as Assistant Vice President in GreyB Operations, and in a lot of consulting projects, we have worked with technical guys and R&D people to understand their need in different type of technology domain, particularly related to packaging, and suggest them some kind of solution for their particular needs. So that is where my expertise lie in, I would say.
So yes, today we'll be focusing on sustainability goals, particularly aligned towards packaging. And first of all, I would also like to thank you for taking out time to join this webinar. And in this webinar, while discussing the sustainability goals and packaging, we'll also be answering variety of questions. For example, what are the variety of materials that are available which are biodegradable in nature? What can be the right replacements to plastics? What type of properties you may need to understand before picking up a material for any specific type of product. So we'll be covering these type of things. And before we start with this, I would like to share that we have seen that companies have kept sustainability goals since so many years, and many companies have also moved towards cardboard based packaging. In case of secondary packaging, many companies have also achieved 80%, 90%, or even 100% sustainability goals. But when it comes to removing the plastics completely out of the packaging, especially the primary packaging, there is still a lot of path to cover, and there is a lot of gap why companies are unable to achieve the 100% sustainability goal. So let us understand first, why is this gap existing? So Arindam, would you like to shed some light on this?
Yes, sure. So, Shikhar, as you were saying, that is a very interesting and right question, that why this sustainability gap is still existing. So, a lot of companies have started on their sustainability goals from long back. So, like Puma or Dell, they have started on their sustainability since 2010. And if you see the research in sustainable bioplastics, you can see that they have also taken a lot of traction in 2003-4, that particular time frame. So, but as you said, this primary packaging thing, it has not been able to remove the plastic from the primary packaging, because one of the primary reasons are government push. So right now you can see that a lot of laws are coming into place, plastics are getting banned. But since a decade back, when the hype started regarding bioplastics, at that point of time there was no particular law which refrained companies from using the plastics, and people are reluctant to shift from plastic to researching a new material, adapting a new material, changing the infrastructure. A lot of price, a lot of money will go in adapting a new material instead of plastic. So along with the cost factor, this reluctance, lack of government push, and lack of steady research also, I will say. So in my screen, you can see that a patent filing chart for PLA in packaging, and you can see that when the hype started in 2004, there has been sharp increase, but after that it kind of became a stagnant. And now recently, when there has been a push again in 2017-16 area, the patent filing again are increasing. So a lack of steady research growth is also a motivating factor, which were not present in bioplastic during this past decade. So all of these factors contributed, and together they hindered the growth of bioplastics over the last decade, and that in turn is the cause for sustainability gap that has been created.
Right, right. So I think this is one interesting factor. Although we can say that external factors like government push that is required, or maybe people are becoming more conscious about their environmental impact, and that is also giving a push towards moving towards sustainable packaging. But in addition to this, do you think that there is some gap in material properties which might not be giving rise to the effective use of packaging, or maybe companies are finding it difficult to still move away from plastics? As far as I understand this domain, there are many companies that are still struggling, although they have 80% of the packaging that is biodegradable or maybe recyclable, but remaining 10%, 20% is still something that they are trying to figure out how to replace. For example, in milk bottles, the addition of black layer just to protect the milk from the effect of light, that makes the packaging non-recyclable just because of the addition of that black film. In certain cases, we have seen that although there are Tetra packs, but there are certain internal layers which companies are still relying on. Those are not fully biodegradable, and majority of those layers are of plastic origin. Considering the fully paper-based packaging is not quite suitable at this point of time. So, do you think that there are right set of materials that can help the companies to get rid of such type of plastic options that are out there?
So, of course, there are like tons of material to choose from, but it completely depends on which industry you are from. So, for example, you give an example of milk. So, in case of milk, let's say grease or resistance or water resistance is one of the primary fact, whereas shelf life is not. So, milk is usually used inside 1 or 2 days of packaging it is consumed. So, there are certain FMCG goods for which shelf life is required. So, depending on industry to industry, there are different biodegradable material from which uh, some material can be selected. And when selecting this particular material, actually there are different parameters that you need to evaluate. So, for example, some materials, they are prepared from biomass. So that is agricultural food like cornstarch or sugarcane. There are some materials which are fossil based but biodegradable. So, for example, one such material can be PBAT. So, all of these materials, they have different type of properties, like in terms of moisture barrier, in terms of rigidity, in terms of temperature resistance. So, all of these needs to be evaluated as a whole from an industry standpoint to understand which particular material to choose from and which one to use.
Absolutely. I feel this is very interesting uh, because many companies consider that if something is coming from nature, that will be appropriate. Something is, uh, let's say, plant based, it will be very effective. But when you are saying that there are options which are of fossil origin but can be biodegradable at the same time. So would you describe some examples uh, and maybe shed some light on the biodegradability of these materials which are of both the origins, agri-based as well as the fossil-based?
Yes, absolutely. So, when we have researched on biodegradability, there are two verticals that we have considered. One is the origin. So, is the bioplastic originated um, from some agricultural goods, or it is originated from fuel? And there are two types of biodegradable conditions which we have evaluated. One is normal biodegradable conditions, and another is industry specific biodegradable conditions. So I'll explain one by one. So first, the origin part. So majorly, agricultural goods like cornstarch or sugarcane or sugar, in fact, it is the main source of all the most of the bioplastics. But there are few bioplastics like PBAT or PCL or PGA like polyglycolic acid. and PBS. So these all are fossil-based material, and in case of this origin, like bio-based or fossil-based, there is like US Department of Agriculture, which actually keeps a track of different materials, and they measure that how much biomass is there in a particular material. So if a company has a sustainability goal and they want to use material which is of renewable origin, then they should see if that material is certified by USDA or not. In fact, if you use USDA certified material for which is USDA certified and bio-based, so you tend to attract federal government budgets as well, like they will invest in EU, and similarly for biodegradability conditions, as well, that you can see in the screen. I have opened a slide where fossil based is highlighted and biodegradable condition normal is highlighted. So these are the materials which does not require any kind of special situations, like any specific temperature or any specific opening to oxygen or any microbes for being biodegradable. They are like biodegradable in normal temperature, whereas these materials are they require some kind of special condition to be biodegradable. And interestingly, I'll particularly highlight PLA because it is one of the major bioplastic that is used and researched because it is claimed to be biodegradable. But PLA is biodegradable only in certain conditions. So industrial compostable factories, they can only biodegrade PLA, not your home composter. So if you have plastic which is made up of PLA, you cannot just throw it away with your regular plastics. It has to be collected properly and taken to the industry for breaking it with microbes at a temperature of around 145 degree Fahrenheit. So all of these intricacies, they are not known to, I'll say, common people, and often at times companies face difficulty in choosing the right material because they are also not aware with these terms like compostable and how it is different from biodegradable, or there is another term which is also confusing, like oxo-degradable. So these are things which a company has to keep track of before they choose any particular material. Like in case of biodegradability, there is also certifying entities, like there is ASTM standard in US and EN 13432, that standard is there in case of Europe. So if a material is certified in all that, then they are like biodegradable and compostable in certain industry conditions. So you have to check those to understand whether you are selecting the right material or not.
Understood. I think it is actually a very good criteria, because even in my experience, I have seen when companies build their strategy, it is very important for them to understand whether the material will be compostable under natural conditions or under industrial conditions, considering many companies would not want to invest in procuring the packaging that they have given to the customer. Maybe they would like the customer himself to dispose the packaging rather than setting up supply chain that will help them collect such type of packaging. So it is one of the important parameters to understand what type of material is suitable as per the strategy they want to have. But Arindam, I think there will be more criteria, considering packaging is going to be dependent on the type of product. There are certain products which might be solid in nature, then there will be certain products which are liquids, then there will be certain products which may have or which are oily in nature. So all these type of product properties are going to impact the type of packaging material that is required. How do you think, companies can proceed ahead? Do we have some example to showcase here how companies can better evaluate how to select the right material for the type of product that they have?
Yes. So I have some information on PLA through which I can explain this particular case. Before moving to the details of PLA, I'd like to say that uh, there can be different requirement for packaging, uh, which you have to understand and think out of the box to adopt a packaging which is particular to your needs. So, for example, let's say if in case of an industry like let's say chocolate industry, if they want to go for uh, edible packaging, so they can select materials like Wikicells, which is like a material which Harvard professor David Edwards has come up with, and it is like a kind of product which is Cheeto Sun, and it is mixed with nuts and small tiny pieces of chocolates and nuts to create a kind of edible packaging. And there are like new materials coming up which are like I was just reading 2 days back about a material called Taptic, and it is having very good properties of plastics and papers. So all of these new materials, coming to the market, companies have tons of options to choose from and evaluate them on a proper basis. So now coming to the PLA, I'll discuss particularly PLA because one of the biodegradable plastics that is primarily used, what a share of market is held by uh, polylactic acid. And in case of PLA, like if you evaluate its lifespan from manufacturing to application and then finally to the composting, uh, one demerit of PLA, I'll say first of all is it is from renewable origin, which is like a two-edged sword. So by two-edged sword, I mean that when you are preparing packaging material from edible material, then there is some kind of ethical and moral dilemma comes up, because you are using the cornstarch or sugar cane or sugar beet, which are like edible material, and people where there is starvation, you are using it to produce bioplastic. So that is a part where people think that PLA is right now lacking, because it is not originates from some kind of seaweed or other kind of renewable waste, but proper edible food is consumed. Whereas when PLA is produced, the carbon dioxide emission and energy consumption is really low, and it is having low manufacturing cost, and it has good moisture barrier properties as well. So that is why one of the uh, use of PLA is as a liner as well. In case of paper-based packaging, it is used as liner because of its moisture barrier properties. However, PLA is let's say brittle kind of in room temperature. So PLA is usually mixed with, let's say, binders or other bioplastics to give it more ductility, so that it can be used as a thermoplastic and make bottles or pouches, these kind of things. So I have listed here, few other properties as well, like heat sensitive or poor oxygen barrier properties, which is like a demerit for PLA when it comes to shelf life. And there is another version of PLA which is like crystallized PLA. It is also called CPLA. So that particular crystallized PLA has different type of properties than the original PLA, and better properties when it comes to heat resistance and shelf life. And after composting, if PLA reaches to a industrial facility where it can be composted, so in that case it does not produce any kind of toxic fumes. But again, I mean, if it is mixed with other plastics, it becomes really difficult to recycle PLA. So this is a broad overview of PLA. So as you can see, in its lifespan, there are different properties which you have to keep in mind to actually use to actually decide whether to use PLA or not for your particular application area?
I think this makes a lot of sense, considering that many people who are dealing with food-based packaging, for them it is a big concern whether it is food grade or not. It is qualifying all the criteria that are made by the government, and another thing is, like you mentioned, that it is having poor oxygen barrier properties, or maybe the type of moisture barrier properties it may have, or oil barrier properties it may have. Uh, this makes it a crucial criteria to evaluate which is the right material. But if I may ask, apart from PLA, do you have any other example which we can say might be better than PLA, considering the type of shortcomings that we have in PLA?
So I have another example of PBAT, that is polybutyrate adipate tetraphthalate. So this one, as we discussed before, it is like prepared from fossil fuel primarily, so which is like again a demerit of it. But when it comes to properties, it is better than PLA because it has 100% biodegradability in normal room temperature, and similar to PLA, it is like it does not leave any kind of toxic residue. And however, when it comes to cost, it is like a little bit expensive, and because it is fossil based, so that is why PBAT is not accepted as a large scale bioplastic. Rather than it is used more as a complementary bioplastic to certain materials like PLA to make them more biodegradable, I will say, in under normal conditions, or make them more ductile so that they can be used to make different kind of shaped packaging, flexible packaging out of them. So that is, like similar to PLA, PBAT also has certain criteria, certain things that are better for them, certain things that are not working for them. Same goes for other type of bioplastics as well. Like if I have to talk about thermoplastic starch, it might seem that thermoplastic starch is a very good material because it is completely renewable, and it is highly biodegradable as well. But thermoplastic starch does not have good marking capability. So if people try to print on them, it becomes difficult to do that on thermoplastic starch. Whereas in case of PLA, it is good. So all these properties, when you are evaluating under different circumstances, different lights, it becomes it is like seeing a matrix, and the ticks, where the ticks are there, based on that and your requirement, whatever it checks on, you have to pick the right material.
This makes sense, and let me also clarify one thing for our audience. We are not advocating here for PLA or PBAT. We are just picked up these materials as an example to showcase that while considering the suitable packaging, it is very important to have the right criteria, evaluate the materials thoroughly based upon a variety of properties that these materials hold. And in addition to this, I do understand that companies have other criteria. For example, what could be the cost of the material? Will the material work on the existing machines? Because many companies, they have their existing setup, which is using plastic sheets to prepare the packaging. So one of the concerns for many companies would be that will shifting to a new material put any pressure on the equipment that is already there? Like my colleague Arindam mentioned, sometimes printability is also an issue. Customers look for attractive packaging, but moving to a sustainable packaging, losing on the attractiveness of the packaging, that is also a trade-off here. Along with this, many people are also concerned whether recyclability is going to be a major issue or not. Do we need to set up a supply chain to take the packaging out of the market, decompose it on our own? We need to have industrial setup for that. So considering all these combination of options while evaluating the materials will give you an edge so that you pick up the right material, move ahead with the suitable option, and then decide what type of option should be picked up. But as we have focused on the pros and cons of these type of materials, you might be thinking that is it that we don't have the right material that can provide good number of advantages, or is it that all the materials they have some drawbacks? So let me ask my colleague to shed some light. Arindam, based upon your research, do you think that there are some options available that can help us overcome the disadvantages of the materials? For example, if here we consider if we have to overcome any weakness like oil barrier property, moisture barrier property, or maybe oxygen barrier property, we need to improve on this, let's say for PLA. So do we have some options available in the market that can help our audience?
Absolutely. So, Shikhar, as PLA is one of the most researched bioplastic, there are a lot of blends available in the market as well as in the research phase. So, as I was discussing about mixing PVAT with other bioplastics, so one of the very common blends that are used is PLA and PVAT blend. So, there are a lot of research available on this. However, I'll say that a large scale commercialization of these blends to overcome drawbacks of PLA is not still being very much applied, because it's like you said that to change the existing setup is difficult, and that is why the total bioplastic market, more than 50% of the bioplastic market, it is only bio-PET or bio-PE, which is like nothing different than normal polyethylene. It's just made of renewable origin. So the green symbols that you see on different consumer goods, in 50 to 60% cases, it is not of any biodegradable material. It's just that the polyethylene that has been used in that material is made from cornstarch or sugarcane, which is the only thing. But it is just normal polyethylene and it will not biodegrade. So coming back to your question, there are different other innovations done on PLA as well. So one of the things that I mentioned in case of PLA was that it is produced from sugarcane or sugar, so which is like edible material. So right now a lot of research has been directed in 2019 towards seeing that whether PLA can be produced from food waste or other different kind of waste like sewage sludge or the shrimp cells. So these kind of things. So one company in China, which is like Novozymes Biotechnology, and they have collaborated with University of Hong Kong to research and commercialize PLA from food waste, and I think that is a very good avenue which can sustain as well as it can give us a renewable future going ahead. And there are big companies also who are researching on PLA and trying to improve PLA. Like here I have noted one example from Dow company, so who are using an acrylic impact modifier to change the PLA properties and use them for transparent packaging. And on the left there is like Biopolymer Network, another company which uses a CO2 foaming technology on the PLA to make EPLA, which is like expanded polylactic acid foam, which has a specific type of strength compared to normal PLA, and it is more shiny, more printable, and they are using it for their plastic packaging. So all of this, innovations are towards PLA, and they are trying to improve different aspects of PLA so that they can fit better in different type of industries.
So based upon this, Arindam, will it be safe to say that majority of the packaging users out there, they are relying on the abundantly available options which are commonly available based upon the number of suppliers out there, and PLA is just one of those options. But if we have to say that what is the best option, there will be different type of solutions that are out there, and maybe if someone is taking time to dig these type of solutions, they will find definitely some better solutions which are biodegradable as well as have good properties, and at the same time will put less pressure on the environment. But at the same time, all that is required to be done is, even if these companies are not packaging manufacturers, maybe they can supply this information to their packaging suppliers so that they can move on to the up-to-date solutions that can be considered for their products. Can we put it like this?
Absolutely, Shikhar. So, as you said, a certain move, certain result from the packaging users has to be there towards the packaging manufacturers so that they totally shift to the sustainable solutions. And I'll say that the quicker the solution will be, the better, because they will then have the early mover advantage. Because going forward, in 2025 or 2030, since governments are pushing a lot towards sustainable future, so they have to be either they have to be converted, actually. I mean, like, there is no other option. And it has been a proven fact that millennials, they like sustainable packaging. The products which are having sustainable packaging, they are being sold more than their traditional typical rivals. And a lot of materials are popping up. Recently I was reading that there is a material called polyethylene furanoate, which is a short form PEF. There has been a lot of interest towards this material also in recent times, and it is being called as a true replacement of polyethylene. Companies have a lot of options. They should research and push towards it more to make our future better and more sustainable, of course.
Great. So audience, what we'll do, we'll take a pause for this webinar here. We do understand that sustainable packaging is a huge domain. So in today's webinar, we are going to take a pause on this one, and maybe in the next webinars, we'll come up with more interesting topics which can be industry specific as well. For example, what type of materials would be suitable for beverages, what type of materials would be suitable for tea packaging, and what type of materials might be relevant for let's say food items that require air barrier properties. So we'll come again with some relevant material for you, and let's hear out the questions from our audience. So guys, you are open to ask questions now. We have kept the next 5 minutes for question answers. Arindam, we have one question coming up here. So this is particularly for juices domain. So here the question is, we have Tetra packs for particularly juices, but those are not fully sustainable. So do you also have some suggestions? I mean, why those are not fully biodegradable? What type of options might be relevant for juices domain?
In case of juices, there is paper packaging, of course, so which is like being used by a lot of companies, and they are researching on the liners on the papers so that they can make the whole thing biodegradable. Right now the liners are mostly plastic based liners, and which makes the juice packaging non-recyclable, but it is like with the use of proper liners, you can make the normal paper based juice packaging as recyclable and biodegradable, as well as PLA is also used as a viable product for juice packaging because it has good moisture barrier properties, and primarily it is the innovation in juice domain. It is uh, very much linked with the type of liners that they are choosing, because that is what differentiates the primary packaging, and grease resistance and water resistance. Those kind of things are being considered over there. So I do not have exact list of the materials that we can use for juices, but definitely, as you said, that when we will cover different application areas, then we can talk about the juices as well in details.
Great. So here we have next question. So this one is, do we have some suggestions for any alternatives to plastic straws? I think I can take this up. So based upon our experience, we have seen that there are numerous options. I mean, paper-based straws, those are very common, but apart from this, we observed straws prepared from bamboo. We have seen straws prepared from wheat, that is like pasta-based straws. Then other type of options we observed were related to uh, the stems of plants which are directly being used, a particular grass that is there in Vietnam. Then we also observed a startup that started providing algae-based straws. But to be very frank, when it comes to the scalability, still there are doubts, considering to enormous use of sea algae may have an impact on the fishes that are there, that are relying on the algae. Too much cutting of plants in a particular region may affect some other aspects, and again, using pasta-based straws again is going to put a pressure on the agriculture domain, considering those are wheat-based. If we consider the raw material, uh, so I can say that yes, there are different options available, but like we have discussed, the evaluation of PLA or PBAT, uh, considering the different options for straws, will require a similar type of evaluation, whether these are scalable in nature or not. Ultimately, these straws will be use and throw. So the evaluation that is required is it going to actually decrease the pressure on environment, or indirectly it is going to put a lot more pressure on the environment, although the option is going to be biodegradable, it is going to be plastic free, but again it can put a lot of pressure on environment. I hope that answers the question. uh, I think we don't have any more questions, so let's end this for today, and stay tuned. We'll be back with more webinars in the packaging space, where we are going to share more knowledge with you regarding the materials specific to different domains, what type of options are available, and definitely we will include some evaluation aspects so that you can consider some of the information for your industry out of these webinars. Thank you, everyone.
Thank you, everyone. Bye bye.
Bye bye. Have a good day.